Welcome to DozoChem. This video covers limiting reagents. Let's take a look at this reaction up top. 2H2 plus O2 goes to 2H2O. So if you look at the coefficients, for every 1 mole of O2 that reacts, you would need 2 moles of H2 to react with it, and you would form 2 moles of water. So imagine before the reaction, you mix 2 moles of H2 and 1 mole of O2, and you haven't made any water yet, so that's 0 moles to start. Then the reaction happens. If all of the oxygen reacts, you end up with 0. If that happens, you're going to need 2 moles of H2 to react with it, so all 2 of these moles will react, and you'll end up with no H2, and you will form 2 moles of water, just based on the mole ratios up top in this balanced equation. But now let's look at this example here. What if before the reaction you had 1 mole of O2 and you mixed it with 3 moles of H2, and then there was no moles of water yet because the reaction hasn't started. Then you run the reaction and all the O2 reacts. So there's no O2 after the reaction. If all the O2 reacts, you'd need 2 moles of H2 to react with it, and you started with 3 moles. So not all of the H2 is going to react. So you're going to have 1 mole of H2 left over afterwards. And if 1 mole of O2 reacts, you'll still make 2 moles of water. So the terms for the chemical that was completely used up, in this case O2, that's called the limiting reagent, also known as limiting reactant. And since the H2, there was some left over after the reaction, you're going to call the H2 the excess reagent or excess reactant. So I'm going to go through an example that you're likely to see for a limiting reactant problem. It gives you a reaction, and they tell you the amounts of the 2 chemicals you mixed, but notice in this case they told you the amounts in grams. So question A, which is the limiting reagent, and what maximum mass of H2O can be formed in the reaction if you mix these amounts of each chemical? So right here is your general strategy. You're going to take the grams of the first reactant and do stoichiometry to figure out grams of the product. In this case, water is mentioned, so that's the product you're interested in. And then you're going to do the same thing for the other reactant, in this case HCl. Do another round of stoichiometry to figure out grams of water produced. If the top grams of water is smaller than reactant 1, in this case MgOH2 would be the limiting reactant. But if the bottom grams of water you get when you do the math here is smaller than reactant 2, or HCl, would be the limiting reactant. To answer the second part of the question, what maximum mass of water can be formed, whatever the smaller grams of water you get, that's your answer to that second part. That's the maximum mass of water you could form. Okay, so this just goes through the steps of the stoichiometry. If you start with 4.1 grams of MgOH2 and you do your mole ratio and switch back to grams, you get 2.5 grams of water. Follow the same method for HCl, but different mole ratio, just based on different coefficients in the chemical equation, and you get 1.8 grams of water. So if you remember from the previous slide, the one that's smaller, 1.8 smaller than 2.5, that's going to tell you the limiting reagent. Since 1.8 is smaller, reactant 2, in this case HCl, is the limiting reagent. And again, the maximum mass of product, in this case water, that can form is the smaller of the 2 grams of water that you calculated. Now there's a second part to this question, which is, remember you added more of the excess reagent than you needed, so the question is how much would be remaining or left over after the reaction. So the steps are, take your smaller grams of product from the previous slide and do stoichiometry to find out how many grams of the excess reactant were used up in the reaction. So here I'm showing the stoichiometry changed the grams of water. That was the smaller number from the previous slide. Change it to moles, then do a mole ratio to find moles of MgOH2 that reacted, and then switch that back to grams. So at this point, what we've calculated is 2.9 grams of MgOH2 were used up in the reaction. Now remember that you started with 4.1 grams. But only 2.9 grams were used up, so therefore you have 1.2 grams MgOH2 remaining or left over. So the excess reactant, always there's a little bit left over, and you can calculate it by subtraction. So these are some of the longer problems you do, but if you follow this series of steps, you should have no problem and end up with the correct answers for both the limiting reagent, identifying it, the grams of product formed, maximum, and the grams of excess reactant left over. So that's it for this video. Good luck.